12x. Well, let's do the numbers first. 3 times something gives me 12. That number must be 4. And now there's no letter here, but I end up with an x. So there must have been an x in there as well. Okay. Now for the second one, I'm actually looking for the number out the front. So that's the factor. Okay. Now what I'm saying is this number, whatever this factor is, times 4y is going to get me 12y squared. So again, we're going to start with something times 4 gets me 12. That thing must be 3. And now there was only one y here, but I've ended up with y squared. So y times y. So there must have been a y out front as well. All right, last one looks a little bit gross. First term times 6x. Well, you're going to get 6x cubed with a y, because I've got x squared times x to the 1. And remember that we're going to add powers when they're the same base. So then we're looking at this second term, and we're saying if I've added an x squared and 1y, what must have already been there? First thing to notice is there's no number here, so whatever number is here must have been just there. Now notice it's actually a negative. Normally what would happen is you just have a minus 4 here, but in this case it's the negative, all right, because we're filling in the blank. Now there's already an x squared, that x squared is from here, and now there's a y to the 5, or 5 y's. Okay, one of those is from this number out the front, which means that there must have already been y to the 4. Alrighty, so here's what we're going to do. We're going to go through 5 more factorising. This is what the real questions are going to look like normally. And then there is one maths-based task for you to do, just called factorising. It's going to be basically a mix-up of these kind of questions. Have a go, post in the teams if you need any help. Otherwise, if you want to ask me privately, you can email me. I'm more than happy to help with any of these. Okay, so factorising. What we're looking for is the biggest number that goes into both terms. There's no number here except for 1 that goes into both, because this doesn't have a number besides 1. So I'm not going to pull a number out. But you'll notice that there's a y here, and I can get rid of one of my y's here. So this is going to be equal to y out the front of, if I get rid of one of these y's, I've just got y left. And if I get rid of that y, I've just got 4. And that's it, factorised. I know I'm correct because I could then expand that and get y squared plus 4y, and you can go back and forth forever. Okay, so for B, I'm looking at it, I'm saying what's the biggest number? It goes into 5 and 40. 5 is a prime number, meaning that there's no other number besides 5 and 1 that go into it. So 5 must be my biggest number because it also goes into 40. And then I'm looking at letters, pronumerals, algebra, that are in both. I can see that I've got k squared here, and I've got k cubed here. Okay, so I can at least pull k squared out the front, and then I can at least pull 1t out the front as well. Okay, if I do that, I've gotten rid of this 5, which leaves me with 1. I've gotten rid of k squared, and I've gotten rid of the t. So I'm just left with 1 for that first term. For the second term, this 5 is going to go into 40 8 times. I got rid of 2 of my k's, which is going to leave me with k to the 1, or just k. And I got rid of 1 of my t's, which is going to leave me with t squared. Okay, now C is a little bit yuckier, all right, because there are 3 terms. It's the same idea though. I'm looking for some constant number that's going to be in all 3 terms, all 3 parts. It should be pretty obvious in these examples. We're going to make it quite nice for you. That 2 is going to go into every single number. So I'm going to write a 2 out the front. Then I'm looking for any algebra, any letters that go into all 3 parts. Now, y is here, here, and here. So I can definitely pull a y out the front. But you'll notice that there's a z here, an x here, and both over here, but there isn't any other letter besides y that is constant through every single term. So 2y is all that I can pull out the front. If I get rid of 2y on that first term, I'm left with 1z, or just z. Now 2 goes into negative 10, negative 5 times, and I got rid of the y, which just leaves me with an x. Finally, 2 goes into 12, 6 times. I got rid of one of the y's, so there's still a y left, and the z's left as well. Whoop, don't forget that there was that x there too. Almost forgot him. So x, y, z. Okay, 2 last ones. These have some negatives, some squareds, just same stuff, just look a little bit scarier. Again, we're going to start with numbers. Is there a number that goes into both 8 and 3? I can't think of one besides 1. And again, 1 doesn't help me. So I'm not pulling a number out the front this time. But you'll notice that there's a w squared here and a w squared here. Now that means I can pull out that whole w squared because that bit is the same in every term. I can't do that with y, so it's just w squared out the front. Now, if I get rid of the w squared here, I'm just left with negative 8 plus 3y. Okay, and for the last term, same idea. There's no number that goes into negative 8 and 9, so I'm not pulling a number out, but you can see there's at least an m in both parts. Not m squared this time, just 1m. So I'm going to pull an m out the front. I'm going to get minus 8 with 1m left over, because I got rid of that squared, plus 9n when I get rid of that n. Cool, and that's all there is on factorising. So again, have a go at that maths-based task called factorising. If you have any questions, please just ask, and have a good week.